In this video, I will show you how to manage processes using TOP. And in order to do so, I'm starting TOP with elevated privileges to ensure that I have access to everything. So what do we see? Well, the TOP interface. And the TOP interface is called TOP because it sorts processes by CPU activity. So you will always see the busiest process listed as number 1. In the 5 header lines, you get some additional information about the system. It starts with some uptime information, number of users that are logged in, and then it's giving you a load average. The load average is giving information about the current workload of the system, and it's expressed in 3 numbers for the last 1, 5, and 15 minutes. Now the number reflects the average number of processes that has been asking for attention. And you know what? Let's just start a couple of processes. I am going to run 3 background processes because it's more interesting to see that TOP is actually showing something. So as you can see, we have the 3 DD processes that are listed as the most active processes, and you can see the load average slowly climbing up. It's an average for the last 1 minute, so it will take about 1 minute until we will see a 3 right here. Now the load average is an indicator of the performance health of your system. Big question is, what is good and what is bad? Well, it all depends on the number of CPUs in your system. And from this interface, we don't see directly how many CPUs there are. The third line is just a summary of all the CPUs that are available. But if you press O1, then you get 1 line for every single CPU. So this is a 2 CPU system. So what does that mean? Well, 2 CPUs means that if we have processes that are asking 100% of CPU attention, the 2 CPUs can only have 2 processes at the same time. So if the load average is higher than the number of CPUs that you have in your system, then you need to investigate what is going on. It's not necessarily a bad situation, but you should investigate what is going on. So on the second line, we can see the number of tasks that is running. The interesting part here is that we can see 4 of them are actively running. Running is for processes that recently have asked CPU attention. And we have 244 sleeping. They are not creating any significant workload. No stopped ones, no zombies. A zombie is a process that has gone into an unmanageable state. And you shouldn't see them at all. And if you see them, well, probably the best thing is either to wait until they go away or to reboot your system to force them to go away. Now we have the CPUs line. Remember, if I press a 1, then I see a summary for all CPUs, and I can press 1 again to toggle for a display that is showing 1 line for every single CPU. In the CPUs line, we can see information about what exactly the CPU is doing. So we can see about 16% in US. US is user space. User space are non-privileged processes. It's typically tasks that are executed by an ordinary user. We have 80% in SY. SY is system space. That is where drivers are involved. And I can tell you, given the workload of DD, where we use DD from one interface to another interface, there it's understandable that the activity in system space is quite high, but normally you should see your activity more in the user space. A very important indicator is ID. ID is for the idle loop. It will tell you how much time your CPU is spending in doing nothing. And the other important parameter is WA. WA means waiting for I/O. And waiting for I/O means that your system is waiting for your disk channel to take care of processing the data. If you have a high number in WA, then there is definitely something not all right in your storage channel, and that's a candidate for optimization. The other parameters are not so very important, so keep an eye on US, SI, ID, and WA, and you can get a pretty good impression of what is going on. Then we have a line for the memory usage. So this system has 4 gigabytes in total, and about 1.2 gigabytes free. Also, we can see about 1.3 gigabytes used and 1400 megabytes in buffer and cache. Now, what is this buffer and cache? Simple. It's all about memory, and this system has 4 gigabytes of memory. Now, Linux is using memory for cache if it is not needed by anything else. Cache is used for recently requested files. And the thing is, if the file is stored in cache, the next time that somebody needs it, it can be serviced from cache, and that makes your system fast. If the memory is not needed for anything else, your data will be kept in cache forever. At some point, your system will reach a state where the memory is needed for something else. And then the Linux kernel is going to clear data from cache if it has not recently been used. Last, we can see the swap parameter. The swap parameter indicates the usage of swap space. Swap space is emulated RAM on disk. So it's kind of overflow, and it is useful in cases where you are completely running out of RAM, because then memory pages can be moved to swap and your system can still continue functioning. Swap is a little bit slower, but the Linux kernel is dealing with swap in a very smart way. It will only move inactive memory pages to swap, if that is possible. And if you only have inactive memory pages in swap, then that just cleans up your RAM, and you can use your RAM for more useful stuff. And that in general is considered to be good. As you can see, we have 2 gigabytes of swap, and 2 gigabytes of swap are free, and nothing is used. The last parameter is not about swap, this is about the total memory. So the total memory is set to more than 2 gigabytes of available memory. Now, the thing that is a little bit confusing here is the relation between free memory and available memory. Now, what is the relation? Free memory is memory that's currently not used for anything at all. You won't always see so much free memory, because if your system has been up for a longer period, then you will have less free memory available. And that is because memory will always be used for caching files. Now, in cache, the Linux kernel keeps track of memory pages that are allocated to cache that have not recently been used. That's what we call inactive cache. And available memory is a summary of inactive cache and free memory. The thing about inactive cache is that if the memory is needed by something else, well, you can just clear the inactive cache, and that makes it we have 2.3 gigabytes of available memory. Right, in the lowest part of the top interface, we can see these processes. For every process, the PID, the user that has started the process, and some more information. The interesting information right here is the CPU percentage and the memory. That's a percentage of CPU that the process is running, and the percentage of memory. And then we can see the names of these processes. Let me go out of top. For now, we have seen enough.